See this API request? It takes around 500 milliseconds for a user trying to log in into our apps. Although I'm running MongoDB in locally and it has around 1 million users in it, and it still takes 500 milliseconds to find a user. Now watch this. I exactly add one line of code in my database schema. I restart my server. I run the exact same login query again. 10 milliseconds. Over 100 times faster. No caching layer, no extra server, no complex architecture changes. Just one line of code. That one line of code is database index. And if you are a backend developer, failing to understand how indexes work is the fastest way to bring your entire application down in production. Today, we are going to learn exactly what they are, how to spot missing ones, and why you shouldn't just put them everywhere. To understand indexes, fork a database for a second. Imagine I hand you a 1,000-page textbook on JavaScript, and I ask you to find every page that mentions closures. If the book does not have an index at the back, what do you have to do? You have to start at page 1 and read every single word until you hit page 1000. In database terms, it is called a collection scan or a full table scan. When you have 100 users, a collection scan is fine. But when you have 100 million users, scanning every row just to see if a user exists will instantly crash your database. Now imagine the book has an index at the back. You flip to see, find closure, and it says page 42, 85, and so on. You go directly to those pages, you just save hours. A database index is exactly the same thing. It is a separate, smaller data structure, usually a B tree, that keeps a specific column sorted with pointer back to original document. It trades a little bit of storage space for a massive amount of read speed. Let's look at a real world example. You have a massive database with millions of users. You write a standard login endpoint that searches for a user by its username. To see what database is actually doing behind the scenes, we use a command called explain execution stats. Now let's look into the output. The database scan type is COLLSCAN. It examined exactly 1 million documents just to find one user trying to log in. The database had to read the entire hard drive. This is your enemy. If you see COLLSCAN in production for a frequent query like login route, you have a ticking time bomb. So, how do we fix it? We index the field we are searching by. In this case, username. In Mongoose, doing this is trivially easy. We go to our schema definition, find username, just add index true. That's it. When Mongoose connects, it will tell MongoDB to build a B-tree index for this field behind the scenes. Let's run the query again. Look at the execution stage now. It says IXSCAN, which is index scan. It examined exactly one document and the time taken went from 500 milliseconds to around 13 milliseconds. But what if we are querying two fields? Imagine building an admin dashboard where you want to find all the active users in a specific country. We could just add index to country. MongoDB will use this index to find everyone in the US and then filter the active status in memory. But if you have 5 million users in US, that memory filter is still slow. Instead, we can use a compound index. User schema.index.country1 status1. The one means ascending order. This tells MongoDB to create a single cheat sheet that sorts first by country, then by status inside that country. It's like a phone book sorted by last name, then first name. Rule of thumb: the order of fields in compound index matters. Put the field with highest cardinality, the most unique values like country first, and field with low cardinality like Boolean statuses second. At this point, you are probably thinking, if indexes make things so fast, why don't I just put index true on every single field in my schema? Because indexes come with massive cost known as a write penalty. Every time you insert, update, or delete a user, the database does not just write to the table, it also has to update every single index that points to that table. It has to resort the B tree. If you have 15 indices on a user table, a single user sign-up triggers 16 total database operations. You made your reads faster, but you made your writes incredibly slow. On top of that, indices exist in RAM to be fast. If you have too many, you will run out of memory and your database will crash. Only index the field you frequently use in your find, where, or order by clauses, nothing more. If this cleared up indexing for you, leave a like for YouTube algorithm. Let's test if you actually paid attention. Here is your video quiz. If I write a query that searches for a user by their email address, but I have never added an index to the email field, what execution status will it show? Put your guess in the comments. Next week, we are diving into advanced AI prompting for backend developers. Subscribe so you don't miss it. I'm Sibil. Keep coding.